Hey there, welcome back to the Ugly Architects, where we dive deep into the worlds of software developments and tech innovations. Today, we are talking a crucial topics that every software professional needs to master. That is, predicting and estimating the number of CPU units required for your web systems. Imagine a situation where your web application is gaining significant traffic, and your user traffic is skyrocketing, and suddenly your server is struggling to accommodate the user required. If you are into situations like this, well, don't worry. In this video, I'm going to show you, or I'm going to break down the science and art of the CPU estimation so you can ensure your web systems run smoothly, even under a heavy load. Sin, a lot of smart folks handle the situations in one of two ways. Either some folks throw out random numbers like let's go with an 8 core CPU or maybe 16 core or why not 32 core. I call them as an astronomical number. The other set of folks I've seen the way people do is let's start small and scale up based on user load. While this approach might seem practical at first glance, they come with big problems. For example, your product owner or stakeholder of the system is left completely in the dark about the infrastructure cost. Without a clear understanding of the resource needed, budgetings become a guesstimations, right? And that is not a great place to be. So most of the time, this feels like a classic chicken and egg situations. In one side, the dev team often say, we cannot estimate the number of CPU needed until we actually develop the software. Whereas the other side, the project management teams always insist saying we need an approximate number of CPUs to do a budgeting plan or before we could start the development. So if you're tired on this endless debate and want to streamline your CPU estimations process, then this is the right place for you. So when it comes to estimating CPU's requirements, there are several approaches you can take. I can show you the most common 5 approach to start with. First off, we have analytical model. This method involves using certain mathematical formulas and algorithms to predict the CPU usage based on specific parameters like what are your user loads, request rates, and processing time. It's a precise approach and one of my favorite approach as well because it gives a clear picture of your system. Next, we have a simulations method. In this approach, you could create a virtual model in terms of doing a load testing on your web applications. Or the best way I've seen is people build a small POC of your web applications, then do a load testing of certain number of users, then look into the response time, then the number of CPU. That's one of the way to work. But remember that if you're following this approach, then at the time of system design, you'll never be able to predict. This is primarily where you already crossed a certain phase of your web application. Then there is another method called historical model. This is absolutely fine where you already have a running applications, you're going through significant performance problem. Then maybe you could analyze the CPU statistics of the currently deployed system and what is the CPU usage. Say, take an example, say you have a web applications which is running on, say, Europe regions, and your business people say that, hey, want to expand to US or North America regions, then I wanted to add, say, 1,000 more users. In that case, what you could do is that you could get a complete CPU dump from last 1 year or 2 years, and then analyze, say, for 1,000 users, your number of CPU is 8, and if you're adding another 1,000 users, so no brainer, right? You could scale up another 8 CPUs. So that is called a historical model. And then I have seen one of the vague and very drastically used method called as rule of thumb. In rule of thumb, people use certain best practices and past experience as well and come out with and predict certain CPUs. For example, assuming like I'm building an web applications for a new system, which is very fairly similar to the other systems, then you could compare, or maybe you could say that, hey, for 10 users, maybe one CPU is enough. Then finally, we have cloud-based elasticity. There, you start with small because of the dynamic scaling aspects. You could see if my number of users are increasing, how many CPU has been utilized, and you could predict. Remember that other than the predictive model, everything else would require a POC or a visible product or an existing product to be deployed. What I'm going to show you is that maybe I could show you the aspects of predictive model, the way I calculate the number of CPU on a very early stage of the software development, so that it give a tentative pictures to my stakeholders saying how much CPUs they need to reserve or they need to provisions. Based on that, what would be the cost? In last 2-3 years, since I've been involved in many cloud projects like AWS and Azure, it provide an calculator or an infrastructure estimator tool, right? But remember that I'm not competing with the pricing calculator of what those cloud platforms do. The first inputs to the pricing calculator of Azure or AWS is that they would ask which plan you would provision, right? If it is a EC2, whether it's a small one, medium, large. If it is Azure, this is based on your B1, D1 or certain plans. Now, these every plans always will have a certain CPU attached to that. So unless until do a capacity planning, you will never be able to know which plan to choose. So this exercise will always help you to choose the right CPU plan on your cloud pricing calculator. So this is one of the prerequisites, and I believe this is one of the most important things. I would show you a little bit around the predictive model and also give you a quick way of how could you calculate. So let's take this examples as part of the problem statement. Assumes you are developing a web applications which is need to be handled in high volumes of traffic, and you want to make sure that your applications can handle the right amount of load efficiently without overloading the CPU. Now, being an architect, you are given the situations to calculate the number of CPUs so that you could choose the appropriate app service plan or AWS or maybe an in-house hardware provisioning, right? Now, as part of the average requirements, you realize that there are 500 requests which need to be processed per seconds. That basically you could get it from the pick user calculations, right? Then there are two implicit requirements. Possibly you need to understand is what could be the average time your CPU may take to process one web request. The industry best practices is 0.01 seconds, but that could differ if you are using a very high data intensive applications. Yeah. And the third most important aspect is what is the CPU utilizations possibly you wanted to say, because remember one thing that you're calculating you are trying to find out the number of CPUs based on the utilizations, right? And primarily this is a web application. So your web application always run on operating system. So if you say that my web server is going to take say 100%, then you are not leaving any rooms for your operating systems. So the best practices is always been 70 to 75% of CPU utilizations. That is that's some good number, so that you are reserving your 20-25% of time or utilizations for your operating systems to do the repetitive job, right? Maybe your memory cleansers, your antivirus, IO disk, and other things. So if you know this fast number using these two below assumptions, you will be able to reach. So the formula what you could use is the number of CPU equal to the request per seconds, that is 500, then multiplied by the CPU time per request, that is 0.01 over here. And what is the CPU utilizations? I prefer 70, but you could take 75, and 80 is also is a good number, but 70 to 80% is one of the best things. Yeah, in this case, I took 0.70. So if you do the simple calculations, you would reach out something say 7.14, right? So you would always see the number of CPU is a whole number, not a fractional number. So, and then average, you know that you would need 7 to 8 number of CPUs. Now, taking this number, you could go to the Azure price calculator if you're trying to use cloud native. Now, last 3 years, I've seen major chunk of your applications go to cloud. The way I do is say, I try to match, if I look for an 8-core CPU, what could be the appropriate plan. And over here, see the P3 V3 model, which may give me 8 cores. And if I choose, it costs me $496 USD per month, right? So that's a way to give it to business stakeholders or to project sponsors, saying, the number of CPUs is 8 core, and that is where this would cost you, say, approximately 500K per month. Now you know that for 500 number of concurrent users, you may need to pay 500 USD. So if the number grow, maybe your budget also need to be provisioned appropriately. And that is the way you calculate. So CPU is one part of your capacity planning. Similarly, you will have memory, network bandwidth, and lot other aspects. Yeah. Maybe in some other time, I would put a video in terms of how you do a capacity planning for your memories, how you do a capacity planning for network bandwidth, so that you could club in, and in one fine day, will be able to do the complete capacity planning so your infrastructure would be required. So that's all. I just thought of giving an example, and the details I will be posted on my blog. You could visit it, and you could use this as part of your as a tool to calculate this.